Hi, welcome to our math. Today I'm doing a series of videos on exponential functions. In this one, what we're doing is we're looking at our exponential functions and just kind of breaking down what the different information is. So the generic of an exponential function is f of x equals c a to the x, where c is your initial value. In other words, 0c is a point on the graph, and a is your growth or decay factor. Okay, so for this first graph, for both of them, we'll do these in tandem. C, our initial value where we cross the vertical axis, is less than 0. Why do we know this? I'm not going to say because it equals -3. The numbers don't need to be there. We're really looking at this graph more as characteristics of the graph, not specifics of this graph. It's less than 0. Why? Because the graph crosses below the horizontal axis. It crosses below the x-axis. In this one, c is greater than 0 because we cross above the horizontal axis. Now you might be saying, why am I saying horizontal instead of x? And the reason is this one's labeled x, but they aren't all. Sometimes this is p of t, and then this is the t-axis, not the x-axis. X is the generic, but really we could have any variables. This allows for the more generalized description of what's going on. Okay. So the next thing we want to talk about is A. A is our growth or decay factor. In this case, and we need to figure out if it's greater than 1, it's growth. If it's less than 1, it's decay, generally. But when it's above the x-axis, I guess below it doesn't work the same way. A, if this was 1, we would have a horizontal line right here. If we move forward in time, if we think of this axis as being time, at 0, we're here. At 1, we're here. At 2, we're all the way here. At 3, we're all the way here. Each of these is going beyond 1. Because we're going beyond 1, A is greater than 1. And I guess it's because we're moving away from the horizontal axis as we move forward in time, as we move forward towards the positive. Okay, for this one, once again, if this is 1, this is less than 1, this is even less, and this is even less, which means we're less than 1. But more than that, we're greater than 0 because the growth or decay factor has to be positive. It has to be greater than 0, but it cannot equal 1 because 1 would be that horizontal line. And it's because the graph decays towards the horizontal axis. Okay, next we're going to look at the domain and range of these graphs. For both of them, the domain is what values of x you could put into your equation, restrictions. Well, this goes forever left and forever right. This goes forever left and forever right. There are no restrictions on our domain. So when we write out our domain, we have a lot of ways we can do it. We could do this by saying all real values of x, so all reals. But we could do the double bar r, which also means all reals. We could use interval notation and say -infinity to +infinity. This is the one I tend to use the most, but every teacher has their own way they like it best. But we also could use inequalities. We could say -infinity is less than x is less than +infinity. And I'm using x this time because the graph actually tells us x. So we can use x this time. Now for the range is restrictions on your vertical axis. Well, if you notice, this graph is getting closer and closer to the x-axis, but it's not crossing, which means this x-axis is something called an asymptote. An asymptote is a barrier the graph cannot cross, or equal for that matter, which means this graph is going to forever get closer to the x-axis, but it's never going to equal it. It's also never going to jump to the other side. Same over here. So for this one, this graph is destined to only be below the x-axis, which means our range is either r of x is less than 0, if you want to do the function notation as it's labeled on the graph, r is less than 0, or if we want to do interval notation again, which is the one I like, it's going to be negative infinity to 0. We use parentheses because it's not going to equal 0. That's why we don't have equal signs here. And we put the negative infinity first because interval notation is based on a number line. And on a number line, negative infinity is always on the left. Okay, for my next graph, and you can see this is where I got that r of x from, this graph is bound to be above that asymptote. So we're going to do the same thing, but this time we're either going to say r of x is greater than 0, we're going to say r is greater than 0, or 0 to infinity. The only time it really matters which of these options you choose is if your teacher tells you or if the directions tell you which to use. That happens a lot when you have online homework where it will tell you very specifically, leave your answer in interval notation, leave your answer as an inequality. So you need to know how to write your answer. When it's paper and pencil, it's usually a little bit more flexible because teachers can read the different answers and see that they all mean the same thing, whereas the computer program might not be that sophisticated. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.